All right. We have, thank you. Yeah.
Unless, do you want him to just finish it now?
No.
Okay, cool. I said no to.
Because when he came in, he was just goofing around the whole time.
Oh, yeah. Okay, cool.
So the answer to the question that we talked about on Friday about the lockers that will be, let me, if I remember this. Did the first person go through and open all the lockers?
Yeah.
Okay.
We were up to 7.
Yeah, up to 7. So the lockers that would have remained open, if we would have gotten our thing right, those would have been open. So the nice thing is, and I said everything in math is a pattern. So the difference between that is 3, 5, 7, 9, etc. So all the perfect squares would be the open lockers once all 1,000 students went through. If you missed the other day, then you don't have no idea what we're talking about. But that's the answer. Okay. So things that are coming on our agenda. We have this coming Friday. This Friday, we are going to have another quiz. Okay? Friends, I'm not going to provide calculators any longer. It's your responsibility to bring one. Okay? I had to go chase one down. It took me 2 periods to find where a calculator went. I'm not providing any more. Okay? Blame 5th period for that. Okay? Get your own calculator. Okay? Oh, I can't. You have an $800 phone right there, but you can't get a $1 calculator? Doubt it. If that's your reason, go find your dean, go find your counselor, and drop my class. You're not welcome to be here. I kid you not. Take responsibility for your education. This is not my education. This is your education. If you're like, oh, can I borrow a calculator because I forgot? Looks like you're counting up. Okay? Figure it out. If you can't figure it out, maybe you should withdraw from class. Okay? I'm being very blunt with that, but it really frustrates me when I provide something, and this happened in my 5th period, so I apologize. I have to chase it down, and the kid was like, literally, cell phone, calculator in their hand, walked out of class. Calculator in hand, walks over, calculator in hand, gets phone, calculator in hand with phone, walks out of class. So I'm not providing calculators anymore. Get your own. Oh, my mom's going to call. Okay, have them call. That's fine. Okay?
Dollar Tree has really good ones for $1.
$1? Well, they're hard to use. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 at the bottom. Add, subtract, multiply, divide. Works. Find it in your junk drawer at home. Okay? Trust me, I know you have them. Okay? You're welcome to use them. If you don't want to use one, don't use one. But get your own. Okay, so Quiz Friday. I am on page 33 of the book. If you don't have the book with you, you can grab a sheet of that paper that's underneath there or use your own sheet of paper. But I want to kind of quickly go through a couple of these. Actually, you know what? I'm going to go to number 2 first. I'm going to number 2. Page 33. Not yet. District. Try that question on that page 33. You can try it on a separate sheet of paper if you'd like. It's up to you. We're going to walk through the evens. What do you know about the odd problems in this class? They're always on Schoology, so go on to Schoology, and if you need help on those, you can. I had about another 15 seconds to make sure we're good, and we'll start going through this. Yeah, Friday. We're going to be using the calculators. It walked.
was my son.
What your shovel? Oh, your shovel's fine.
Okay.
Your shovel has nothing to do with that. It's just-
I'm wondering.
Well, they're big boys and girls. They can figure it out for themselves. All right, my friends, why did I highlight the -3? Go ahead. I'm sorry?
It's negative, and that's what's the first step.
First step. So what am I going to do with that -3? I love where you're going with this.
And distribute to the 6 and 2.
Is that what you're going to say? Love it. We are going to distribute. It's going to distribute here and here. Okay? So a lot of people will make the error. They like, oh, I'm going to combine 2x minus 3 together. Okay? But no, the order is going to be this 2x comes down, part of the ride. What's -3 times 6x? -18x. What is -3 times -2? -3 times -2? +6. It happens. It happens. All right. Talk to me, friends. What does it look like we probably should do next? Combine like terms. Yeah. So those are like terms. So 2 subtract 18 is -16. 2x minus 18x must be what? -16x. Good. Notice I have not moved anything back and forth across the equal sign. Agree? Am I ready to start moving things back and forth? Cool. All right. So, we have this and this. Why did I subtract 6 and not add 6? Yeah, it's already a +6, so I want to make sure I don't do that. Okay? So I get -16x is equal to, -70, right? So something costs $64, something costs $60 or $6. I owe 70. And then I'm going to divide both sides by -16. Negative over negative is positive. Okay. So let's think about this. I don't think that's going to work out to a whole number.
No,
Miss Stone, you think whole number?
I calculated it. It's gonna be like 4.4 if you round it.
Oh, but I want to keep it as a fraction. I don't want to keep it as a decimal.
Yeah.
What do I do to figure out the reduced fraction? What number do you think goes both top and bottom? Go ahead.
4? -4?
4. 4 won't go into 70. 6 doesn't go into either. What's a real easy number to start with? 2. Well, 1's real easy, right? But you get the same thing out. But if we go 2 on both top and bottom, 2 times what gives me 70? Good. And 2 times what gives me 16? 35 over 8. And please, friends, just leave it like that. If you were trying, don't give me a decimal approximate. I want an exact answer. Okay? Now, I'm not going to mark you wrong. I'm just trying to guide you that it's more preferred to have an exact answer as a fraction and not a decimal. Friends, can I move off this problem and move to number 4?
Yes.
While I'm moving to number 4 and writing it down, would you go ahead and get a start on it, and I'll write it up on my board. Take a look. This one looks pretty similar. Might not have as many negative signs, but it's pretty similar. Talk to me, friends. What would you like to do? Talk to me. Go ahead. Yeah, go ahead.
Oh.
You got this.
So you plug the 3 into x and then 2.
Yeah, so you're going to distribute that over like that? Is that what you're thinking? You're awesome. Good job. All right, so 2x comes down for the ride. 3 times x is? 3 times x is what? 3x. 3 times 2 is? 6 equals 8. Should I start moving things back and forth across the equal sign right now? No, I have some like terms, right? What are those like terms combined to? Cool. Now I'm at the point that I could start moving things around. Agree? So it's positive 6, so I'm going to do, I think I heard it, subtract 6. Like it. Those cancel. 2 over 5? Is 2 over 5 a reduced fraction? Sure is. That's a great answer. I like it. Remind me when I write in red not to use the pink highlighter. It doesn't look quite as clear.
Does it look more clear on your screen?
Kind of, sort of.
Kind of, sort of.
Well, we found out in my stats class we were using Desmos, and on this screen it looked like it was a negative number, but it was equal to a number. On this screen you could totally see it was equal to a number, and we were finding standard deviation because it was never negative.
Right.
And the kids are like, "You said it's negative, but it's negative there." And I'm like, "But it's equal there." And they're like,
Oh, that's
so that's like, old school. This is higher definition, I guess. More pixels or something.
yeah, that is weird.
All right, friends. So okay to go to number 6?
Yeah.
Actually, yeah, let's do that. Let's go to number 6. So we're going to go there. That's should be quicker, right? Talk to me. Distribute what? The 4. Here and here, correct?
Yes.
I love it. So I get 6n. 4 times n is 4n this week. 4 times negative 3, negative 12. Those cancel. What do you get? And a negative over a positive is a negative. 12 over 2 is negative 6. Don't forget the negative sign. You don't want to miss the negative. That's 1 point off. All right. So now, my friends, if you take a look at 1, 3, and 5, those are all clear and fraction ones. I want you to try those. Of course, the video is up, but I want to go through the word problems because I want to mimic what we're going to do with the word problems when we have the quiz. And I need to make this stick to the right region. Yeah, we'll have to do. Our assignment's going to get the rest of this done, but I want to go over the word problems. All right, so problem number 7 says half the difference. Ooh, difference with 3 R's. Between a number and 12 is 15. Okay. Half the difference between a number and 12 is 15. There's kind of a lot up here. So let me highlight. This is about what I would highlight on a quiz, and then I'm going to build upon that. That means something. Agree?
Yeah.
This also means something in the world of math. And then between a number and 12, that also means something. So the stuff that's in blue is going to be on one side. The stuff that's on red is going to be the middle and the other side. Okay, So during a test or quiz, I would probably highlight that. Like the only words you didn't highlight was the. Sorry. So let's now kind of start sawing through what we know. And during the test, I'd be like, okay, put down on your paper what you think half would mean. Well, friends, what does half mean to you? 1/2? Is that okay so far? Make sense? Now, I probably would not write that down for a test or quiz, but I would probably say, half, what does it mean to you? You're going to have to do it on your own. What does the word difference mean in math? Subtract. Love it. And then a number and 12. A number is an unknown. So what is an unknown in math? It's a variable, so we'll call it x. Does anyone know what the word is means in math? Equals. Okay. So far, I have a lot of information up there. I feel comfortable so far with this. Do you agree?
Yes.
Is 15? I know I have equals 15. Agree?
Yes.
Golly. Hang on. Difference between a number and 12. What do you think? A difference between a number and 12. I'm just trying to figure out a difference between a number and 12. You're throwing all these numbers at me, and there's not. You're just trying to shoot fish in a barrel on that one. Think about what I have written up there. Difference means what? Difference means what? Subtract. Number means x. 12 means 12. How would you write difference between a number and 12? I love it. X minus 12. Very good. Okay. We're almost done sawing through this. There's a lot of information with only a few words. Half the difference. What do you think I should do with half? Yeah. Could be division. Divide by 2. I like it. I like it. So I have a half that needs to go someplace. I'll just put it right here for right now. Half the difference between a number and 12. I'm missing something so far. The equals 15, 100%. The numbers, the 1/2, the x minus 12, it's all good so far. But I'm missing one thing. Yeah. Brackets or parentheses. Yeah. Where do you want to put those around? I love it. All right. Now let's read this again and make sure this makes sense. Half the difference between a number and 12 is 15. Is 15 equals 15 should be all day long. Half the difference between a number and 12. So it means I'm going to do the difference between a number and 12, a number I don't know. So we're going to call it X or Y or Z or some letter. And I want to do half the difference. So this was definitely a grouped problem. Okay. Now, my friends, I will highlight certain words, and hopefully we have a lot less words that are part of it on the test. And then I'll probably give you some things saying, half means what in math? I mean, if half means 1/2, we'll put 1/2. Difference, it's got to mean subtraction. You've probably heard that term before. But once you get it done, take a look. Does this number argument, this problem we have written, does it make sense to what is typed?
Yeah.
All right, so if we feel comfortable so far with it, where should I go next to solve this problem? You want to distribute half? I like it. What's another way?
Times the half.
Okay, so So if I distribute the half, I get half x minus 6. So I still have a fraction, which your answer is going to be the same. And you can think it that way all day long, and it's fine. So distributing the half might be a really viable way of doing this. Or I could realize I have a denominator of 2, so I'm going to multiply both sides, and look what happens. 1 times parentheses equals 30. 1 times parentheses, what happens with that 1? Yeah, distribute the 1, I get what's inside the parentheses, right? Add 12 to both sides. And friends, I know we spent a lot of time on this. And I'm going to be real honest. The grammar that math people use is horrible. I'm not going to try and defend the grammar. So if you took this question to your English teacher, your English teacher would be like, nope. You got a predicate nominative, you got an adjective before an adverb after an ad. All this kind of. They're going to rip this. Math people just. It's always been horrible. Stone, you agree?
Mm-hmm. That's why I don't teach language arts, because my grammar is no real good.
Yeah, it's bad.
Mm-hmm.
It's bad. I mean, so we're ripping on ourselves. It's a good thing we teach math because we would fail at. Oh, I might cry myself to sleep knowing that. That'd be scary.
Hey, Stirrup,
Talk to me.
question.
Talk.
What if we didn't answer that? What if we just got that equation and didn't answer it? Because it didn't say solve.
Oh, okay.
So.
The directions above say translate the following sentences into mathematical equations and then solve. So let's talk about this problem. I would say this is probably a 4-point problem overall. Y'all know that I like options, yes? So the highlighted portion is what I did. Agree? I would have done that for you in before class. So you know this is worth 4 points. If you leave it blank, you get 0 points. 0 points isn't good. Let's see how we can start getting some points. I'm going to highlight the first points. If you add something kind of just to that effect, there's 1 point. Okay? So you get 1 out of 4 points. It's still bad, but it's 1 more point than you had. If you tried to set it up, there's your other set of points. What did I just say? Tried to set it up. So here's your third point. If you went to solve it and you had some steps shown, but you might have gotten the answer wrong, there's 3 points. And then if you have the answer correct with the work shown, my friends, I'm going to tell you something. If you gave only this and there's nothing else shown, you're getting 1 out of 4 points. But I got it right. The directions say translate the following sentences into mathematical equations and solve. Answer only on this one, 1 out of 4 points. Yeah, but I got it right. You didn't answer what was asked. Okay? I'm showing you how to get the points. The half, the minus, the x, the equals, there's 1 point. Set up an equation, there's a 2nd point. Show some mathematical work according to your equation, there's 3 points. Get the answer correct, there's your 4 out of 4. Answer only, no other work shown, 1 out of 4 points. Again, friends, I'm trying to give you the options that are available, not anything. Yeah.
So say if you want like all that and then got the answer wrong.
3 out of 4 points. That's 75%. That's better than half. All right. All right, let's take a look at how we're doing on time. What time are we at here? 11? Oh, we got plenty of time. Too much to do. Oh, wait. Didn't Willy Wonka say that? Number 9. The sum of 3 times a number. I did. You can find number 8. And 6 is 27. Okay. All right, so let's read it first out loud. The sum of 3 times a number and 6 is 27. So let me highlight a few things. Sum 3 times a number and 6. So that's got to be something. And then I'm going to change color. Is 27. Okay. So let's start putting a few things that we would know. Let's try. This is going to be a 4-point problem. Let's see if we can get the first point. What do you think I should start putting? Go ahead. Is equal.
Sum is add.
Sum is add.
X is number.
X is number. I like it. Okay. That might get you 1 point if you just had that. Three, the sum of 3 times a number and 6. Do you think we need parentheses? We might. I don't know. Hang on. Let's get this. Yeah, go ahead. Okay, so let's see if we can decipher this without parentheses or with parentheses. We'll figure out one or the other. I like the thought. The sum of 3 times a number and 6.
Would be 3x plus 6 equals 27.
All right, so 3 times a number, so 3 times this, and 6. Problem. I don't know if I need parentheses. The sum of, I'm going to take some number, I'm going to go 3 times that, and then I'm going to sum it with 6, is 27. The sum of 3 times a number and 6 is 27. What do you think? I don't know, maybe. Could be.
Subtract 6 from both sides.
Well, first off, do we feel comfortable with that equation? Because I know there was, or is it this? So how are we going to get how are we going to decipher the between the two? Because they're two completely different problems, though with the same answers. It's just I have a grouping stuff in there. The sum of 3 times a number and 6. The sum of 3 times a number and 6.
I think might be sense if here it says the sum. I don't know.
I think the key, though, on looking at this and just trying to saw through it, 3 times a number means something. And I think that's where the 3x comes up. I think that's where, so this portion here, I feel really comfortable with. Sum, I got an addition sign. 6, I have. I think we can rule this out once we've kind of thought through it a little bit. Okay? Now, you all are so much better at grammar than I am. So, saw through it. Okay? So right now we have 2 of the 4 points. I think I can start solving this. Agree? And as you said, x equals 7. Good deal. All right. So first point, getting the plus, the 3, the x, the 6, the equal sign, even if you wrote 27 down, that's going to get you 1 point. Writing down some sort of equation, it might be wrong. It might be wrong. Now here's the key. If you've written down an equation, you have the above and write down an equation, you're going to get 2 points. If you write the equation, let's say you wrote the equation 3 parentheses x plus 6 equals 27, you're still going to get a point for that because you wrote an equation down. So now it's 2 out of the 4 points.
Sir,
Yeah.
I think we need this. Because it says 3 times, it means 3 is getting multiplied by the number. That's what I think.
That's wrong.
The sum of 3 times the number and 6. Okay, let's do this.
Because they're doing it 3 times.
Okay,
Actually,
let's take out of the whole thought process 3 times the number. You still with me? A number and 6. The sum of a number and 6. The sum of a number and 6. That's just x plus 6, right? The sum of 3 times a number and 6. I think we could chase the dog around a tree on this one a lot. It's really hard on these kind of problems, and I don't think this is a very fair problem to give, because I agree with the argument, and here's the worst part of the argument. I would tell you this. If you were to set it up the wrong way, you get some really dorky looking fraction, but you don't. You get either x equals 3 or x equals 7, depending upon how you solve it, which that's mean. So you know what I'm going to do?
Yeah.
So we're going to do this. We're going to do this, okay? On the quiz, I'm going to make sure one way has the worst looking fraction in the world, like 256 over 726,281. Or the other way, if you did it, you get like x equals 2. And it'll be like the easier, like x equals 2. Deal? Because I think this is a really bad problem. I know what we're trying to do with this problem, but I understand the argument. And I think it's a very valid argument. So, all right, let's get away from this one. We got it gets goofy. You can chase your dog around a tree like crazy. What? Yeah, we will. All right. On page 10, they have a word problem, and you will see this definitely on the test. So they have this problem worked out. Okay, so the word problem says McKenna solved the following equation incorrectly. So this was McKenna's work, and it's wrong. Circle her mistake. Circle her mistake. Does anyone see where the mistake is? Go ahead.
Oh, not yet.
Not yet?
Um,
Yeah. Here's the mistake. She forgot to bring this down. Okay? There's your first point. You identify where the mistake was made. Okay? So then it says, then rework it correctly. Now, I will assure you this, just so no one's going to do this. Oops. I will make sure there is a mistake on the problem. I had students in the past, there's no mistake, and there is a mistake. So if you're like, nope, there's no mistake, no, I'm telling you there's a mistake. So notice the answer that she originally got was positive 6, but the correct answer is negative 6. So this is probably a 3-point problem. You tell me where the mistake is, setting it up the correct way, getting through and solving. There's 2 of your 3 points. Get the correct answer is 3 out of 3. I got 9 minutes, right? Oh, boy.
understanding the point system. So I would hate to like grade your guys' quizzes and be like, oh, they're correct, but they like aren't showing the work or they didn't read the problem. Are you understanding like what it's looking like for the test?
That's the main thing. Showing your thought process. Oh, but I can do it in my head. That's middle school. You're not in middle school, friends. Please show the work. All right, one last problem I want to do. I'm going to do number 12. Now, this is kind of goofy. Find two consecutive integers with a sum of 29. Oh my gosh. Oh yeah. Find two consecutive integers with a sum of 29. So the only thing I could probably tell you that I know definitely is of is like is. It means equals. I think we're good here. And I think we're good with sum. What in the heck is an integer?
It's like a number,
Is it a number?
just a number.
It's a number. What kind of number? Yeah. It is, but what is an integer?
Any number, negative, positive.
Could be a negative or positive, could be a fraction. Could it be a decimal?
It's like so long ago that I.
Yeah, it's been a while. So an integer is, it could be positive, it could be negative, but it has to be a number that's like 3 or 7 or 12. It can't be a fraction, it can't be a decimal. Okay? What in the heck does the word consecutive mean?
One right after the other.
Thank you. One right after the other. All right, so I'm going to write down some integers. These are all integers. Agree? So to go from here to here, here to here, here to here, here to here, here to here. How much did I increase by? 1. So I have two integers with a sum. If the first integer is x, and I want to find the next consecutive integer, what number do I have to add to x to get to the next integer? 1. Good. X and x plus 1. This is your first number. This is your second number. Okay? My friends, can we work something like that out? Yeah, what's x plus x? So we get that? Solve it. Divide by 2. Okay, so if we wanted to find the two integers, 14, what does this one have to be then? 15. Is 14 plus 15 29? Are 14 and 15 consecutive integers? Okay. My friends, again, we're reviewing quite a bit this week. I want you to make sure you have page 33 and 34 complete for tomorrow. There's going to be 2 lessons for today. The one I just did, there's one I did earlier, that's like 15 minutes, all the problems worked out. Or if you look in the folder, you're going to see that. Okay?